Yes, I think
Or
it's
do we
working.
need to switch to a Zoom that you start?
That's recording now, so that's good.
Okay.
Right. So, are you satisfied with my answer?
Yeah, where are you now? Are you at a university in Sweden?
No, no. I'm a grown up. I I I'm 47 now,
Mm-hmm.
so I have a
No,
kid of my own. So I that was quite a while ago since I was at the university.
no, I was wondering if you are working at a university now.
Right. No, I'm no academic at all.
Ah, I see. Okay.
I mostly do embedded programming as a contractor,
Mm-hmm.
various companies.
Ah, very nice.
So I'm kind of familiar with ITS feels kind of familiar because it's a lot of assembly language programming and so on.
Yeah, right, right. Well, what can I help you with?
Well, I'm looking into the robotics group, the mini robots group, a little bit.
Mm-hmm.
And one thing I did see that I'm being curious about for a while is about the GT40
Mm-hmm. Sure.
PDP-11 display,
Mm-hmm.
which I understand you had one of. And
Mm-hmm. Yeah,
I'm just
that's
trying to
right.
find someone to remember if there were one or if there were two of them.
Uh, as I recall, there was only one GT40. Yeah, because that had both a graphics processor and a PDP-11 essentially inside it,
Right.
and it was a vector-based graphics
Yes.
system. In fact, we one of the fun projects I did with that back in the early '70s during the gas crisis. That was the beginning of OPEC, the Arab
Oh,
countries jacking up the price of gas. So there were long lines at gas stations.
right.
And so we wanted to make a game, and we thought of Monopoly, but Monopoly was sort of boring to do on a GT40. So instead, we decided to take the idea of, make a sort of a porthole version of Monopoly where you were driving around Atlantic City.
Oh,
And then the funny part was how to deal with rolling the dice and doubles and stuff. So rolling the dice was that gas was super expensive, but cars hadn't changed, so you had to buy a little bit of gas, and it would go only so far, and then you would run out of gas. So that
right.
was the equivalent of the dice rolling. And the doubles was done by finding a car nearby without a locking gas cap and
Right.
siphoning off some gas to keep going. But yeah, it was
You
yeah,
had
I remember
a
the
you had
GT.
that little game going.
What's that?
Yeah, you had that little game going.
Yeah, we had the beginnings of it. What we were
Right.
planning on doing was connecting it to the list machines down the hall. You know, the PDP 10 and stuff like that, and doing some fun stuff. But that never got too far. But we did the beginnings of the graphics for driving around Atlantic City, which was fun.
Right. Right. I actually did see something about Monopoly because I have been in touch with MIT and I've been bugging them about the backup tapes. And
Ah,
finally, they relented and they gave me access, so I can actually
no,
see their backup tapes and see all the
okay.
files in there for research only. I'm not allowed to give out the
Yes,
files to anyone.
right, right.
Mm. So
Yeah.
I did
Well, I
see.
think I was in those days, I was doing a lot of assembly language code, and might have already been doing some C programming in those days. I probably was, as we were running Unix on the PDP-11.
Right.
So there was a PDP-11 and then a separate GT40, as I
Yes.
recall. Yeah, that's my recollection of the place. And then, of course, we had the camera system and one or two the robotic arms sort of varied over the years,
Okay.
and but and then there were what we were doing, because the vision stuff was so primitive, we would put markers on the arms to make it easier to spot where the arms
Yeah,
were in
sure.
space.
All right.
Yeah, it's yeah. I mean, I always joke that the machines I was using back in those days are dwarfed by the average microwave oven now.
Yeah, sure.
They were, yeah. The big thing on the PDB-11 is it had separate instruction and data space, ID space. So you had 16 bits of each. So it
Yeah.
was a
Should be
functionally
plenty for anyone.
a 17-bit computer.
Right.
Yeah. Right.
So I
But
saw you wrote an AI lab memo about your program Mapper.
mhm.
Is that anything you remember about that?
I believe that was a tool I wrote to make it easy for various people to do image, get access to the cameras and do some very simplistic image processing. You know,
Right.
just looking at very simple analysis histograms. You know, I was taking a quick look. I found that paper online. It was talking about buckets, and that's what is that buckets are the ranges in histograms,
Right. Yeah.
right? And so it was, you know, super simple stuff. And then I did my main work at the Mini Robot Lab was my undergraduate thesis was on trying to find defects in solder joints. And I probably have that paper in the basement somewhere. I haven't found it yet.
Okay.
But the idea there was that most people, if you look at the early vision work from the early 70s, maybe even late 60s, people would take perfect blocks under perfect lighting and then try to find them, you know, which was a good way to start. But then I thought, well, this problem is much more interesting because first of all, it's not, things aren't square, they're round.
Right.
And in fact, when solder joints are bad, they tend to be less round,
Okay.
right?
Mm.
And they're also three-dimensionally curved. And when a solder joint works well, it's actually mirroring the stuff around it in the room. So what you see in the image is this sort of interesting reflection of stuff in the room. But if a solder joint is bad, it's called a cold solder joint that
Yes.
doesn't have proper connectivity. It often has a frosted look.
Right.
And so it was sort of an interesting problem to work on because it didn't have any straight lines and it had this mirroring effect and stuff
Yeah.
like that. And then and part of that paper, if I could find it, the interesting part was actually the appendix where I looked at some other papers that were using histogram analysis to do this kind of thing, which I knew wouldn't work because that was the first thing I tried. Right. So
Right.
nowadays, of course, you know, they're using um, neural networks and pattern recognition and all kinds of things.
Right.
It's a very early work trying to struggle with how do you deal with things that don't have straight lines
Yeah,
and
sure. You have to
stuff.
start somewhere, right?
What's that? You
You
got to
have to
start
start
somewhere.
somewhere.
Right, right. And then the other work I remember doing there was on color vision. So I did my master's thesis on color vision, which was interesting. I mean, the cameras that we were using were super low resolution and super bad. Any way you look at it. Uh, you know, the very earliest digital cameras were much, much better than what we were using in those days back in the early 70s.
Right.
But the interesting problem there is uh, was trying to compare algorithms to what we knew about visual neurophysiology in the early 70s, which was that, about not only your vision coming out of, the cones and rods in the eye, but also the processing that happens. The optic nerves go into a area of the brain called the lateral genicular nuclei, LGN,
Okay.
which does differential analysis of
Right.
the data coming in.
Yeah.
So a lot of the information about any kind of absolute value goes away in that process. So that was sort of another interesting topic to work on, is how to recognize colors, trying to leverage what was known about the biology at that point
Right.
in time.
Yeah.
I'm sure that's gone a long ways farther too.
Yeah. Probably.
But yeah, I mean, so this is now, 45 years ago. It's a long
Right.
time ago.
Yeah. I'm happy someone remembers something at all at this point.
Yeah, particularly me. I don't have a very good memory, so so it's spotty at best.
Sure.
But yeah, my recollection of Mapper was it was just a tool you could use on the GT40 to pull in pictures, look at them, and then do some very simple analysis,
Okay.
and then save them off.
Right.
And it looked from, I just took a glance at that paper this morning. It looks like you could also essentially print off character-oriented versions of this. The printer we had was the Xerox. We had probably one of the first Xerox printers,
Yes. Yeah.
because everything was character-oriented
Okay.
in those days.
Yeah.
Very primitive compared to, uh, obviously to what we have now. And so it would print off character-oriented versions of images using characters, various kinds of character sets, and that could be printed on regular printers.
Right.
But yeah, that was yeah, and I'm trying to remember what else we did. Well, I used to do a lot of stuff on the sort of macro languages that eventually became Emacs later on,
Right.
in terms of tool building. Yeah, working on editors. In fact, I worked for both Beranek and Newman years later, and wrote an editor for them called Pen.
Yeah, I actually checked my email archives and I see we talked about that like 5 years ago. So
Uh-huh.
I'm
Right.
since Emacs is an important part of ITS, I'm kind of curious about Emacs as well.
Yeah. Um, yeah, so my memories are a bit foggy of those days.
Sure, sure.
uh, yeah, so did you get the code for Mapper, or is that how this came about? Off the tape?
Yeah, sure. It's in there on the backup tapes.
Mm-hmm. Yeah. Well, one thing I found sort of interesting, when I had years ago looked at some of that old assembly language code and saw sort of things in the style of how I was doing it that I would end up doing much later. I was a very early user of object-oriented programming
Oh,
languages.
nice.
I used to teach occasionally at the Usenix technical conferences,
Okay.
introduction to object-oriented programming languages, and it was actually a very fun thing to do. Because what I did is I took like 6 of them maybe, and then I showed that like in a Venn diagram, that the interesting good stuff about them was where they overlapped,
Right.
things that they all had. And then and then looked at, like, that was in the morning, and in the afternoon, it was like an all day thing. And then in the afternoon, how they differed. And then I went back and found the papers of the people that wrote these languages
Okay.
and why they decided to write them. And the differences then became completely apparent. Okay, because the differences in the languages were driven by what they were trying to do.
Sure.
Right? And they were very successful in their own right. So
Right.
people have a tendency to have religious wars over languages, to say,
Right.
oh, you know,
That hasn't changed.
no, no, it's, it's one of those things.
Yeah.
But if you go and actually study these languages, you'll find that, like a good example is C++, right? Because
Right.
C was written to write phone switches and take it out of assembly language and put it into a higher level language. That came out of Bell Labs. And C++, which also came out of Bell Labs, was designed to do a better job of writing phone switches,
Right.
which, you're very familiar with real-time things.
Yes.
So there were things that had existed in languages since Lisp, right, that you didn't want to put into a language that was doing a real-time problem like phone switching,
Right.
right? And so it wasn't like the people who use C++ didn't know about all these things. They did, but they made these decisions based on the problem they were trying to solve.
Yeah, of course.
So it's that kind of perspective that people don't often have when they look at languages and they say, well, Java is much better than C++
Right.
or
Yeah.
vice versa or whatever.
There's no single best tool for the job.
No, no, no. And it takes work to understand which tool might be best.
Right.
Right? That actually takes effort.
Yeah, yeah.
Most
Often
people
you
don't
just fall
do
back to what's familiar from before.
it. Right. Well, were there other things that you came across?
Well, I'm curious, do you remember if you mostly worked on your PDP-11 computers, or did you sometimes use the PDP-10 as well?
Yeah, I did both. Yeah, which was a little, yeah, I used to just try to describe what that was like. So I was doing assembly language on the PDP-11 and Lisp on the PDP-10.
Okay.
So it was
Yeah.
like the two opposite ends of the spectrum in terms
Because
of
I got the impression from other people in the mini robot lab that they mostly use the PDP-11.
Yeah, yeah. Well, people that were doing the robotics stuff for sure. Trying to remember if there were if there were other people doing a lot of vision stuff. My memory for names and people is at that far back is very fuzzy.
I suppose Horn was the head of
Yeah,
the
Bert
robotics
Horn
lab.
was my advisor. Yeah,
Right.
and Pat Winston. He was running the lab, and then Marvin Minsky was my graduate advisor.
Right.
So yeah, I stayed on after undergraduate to work at the lab. But yeah, so I was very involved in the Lisp stuff, not so much in the building of the Lisp environment. There were a lot of people working on that, but more as a user of it to
Right.
try to do higher level things.
Yeah.
And I was, yeah, as I mentioned, I was sort of interested in how to combine those things together to have,
Right.
some Lisp-based intelligence running things out of the mini robot lab, although the protocols for doing that we all take for granted now
Right.
didn't exist in those days.
No.
So yeah, we had the whole concept of networking has changed so much over the years.
Yeah, sure. Every little gadget
Networking,
is connected now.
yeah, back in the early 70s, network, yeah, we were on the ARPANET, of course,
Yeah.
and we were working probably more with Stanford than anybody else in those days, at least for my work. And there was some there was some live stuff going on, but it was really a lot about file transferring and things
Right.
like that. Yeah, we had remember a funny story. There was a very primitive pixel-based display on the PDP-10.
Right.
Okay, so
The
instead of
night
using
TV.
vector-based or character-based displays, it was raster, so
Right.
you could and then Stanford had a set of these, and we came up with a way of connecting these, essentially doing screen sharing
Oh,
back
okay.
in it might have been 75 or something, 76. And so and there was also this program. It was sort of a joke, but called Eliza. It's
Yeah.
sort of this joke
Yes.
about psychiatrists that turned into this program where we turn whatever you said into a question.
Yeah.
Right? So we had told the people, as this must have been very late one night, we told the people at Stanford we'd come up with a new version of it, right? And so they would ask questions, but instead of attaching it to a program, we were sitting there huddled around this thing typing at it, right? So we were pretending to be this new version of Eliza.
Yeah,
And
nice
then,
prank.
it was late at night and people were doing typos and stuff, right? So everybody had to catch the typos so you could insert that word again and mistype it the same way to make it look like it was a machine.
Right.
That's yeah, funny stuff like that. But yeah, that was the first time I had seen screen film. It
Cool.
might have existed before then, but you obviously needed the right kind of displays for that.
Yeah.
Yeah, but yeah, no, it was a great place to work. I really,
Yeah.
that's
I
why
can
I
see that.
hung around. And yeah, we used to. There was a ping pong table right outside the mini robot lab room, and Rich Greenblatt, who was one of the major Lisp guys, was an avid ping pong player. So it'd be 2 or 3 in the morning, and we want to wake up and we go play a game of ping pong.
Yeah, that's nice.
So it was a fun place to work. Yeah.
So that Boston Dynamics founder, did he work there too?
Mark Raver, yeah. So yeah, you might. I don't. I remember him being around. I don't remember, and I remember him doing some robotic stuff, but my recollections of that are very fuzzy. If you can get a hold of him, he might have some
Okay.
uh, other things, memories of that
Sure.
era.
I'll try to get hold of
Yeah,
him.
if you look up Boston Dynamics, they're the ones that do all those dogs and
Yeah.
dancing
I've seen the
robots.
videos.
They're big
Right.
on YouTube and stuff. He's made
Yes.
enormous progress in robotics,
Yeah, it's
or he
quite
and
impressive.
his company. Yeah, that's right. Yeah, I admire the work that they've been doing.
Yeah.
Really great stuff. Yeah, but yeah, no, it was a pretty small group of us that were working. It was a pretty small room for one thing, so it wasn't like a giant. Yeah, it was just. I think it was one of the offices. We were up on I think the 6th floor, and where the AI lab was, and we had one of the offices, and we kind of loaded it up with robotic stuff,
Okay.
and we had gotten, in those days, AT&T couldn't compete with IBM in the computer business, right?
Right.
So they developed this, Unix operating system and C programming language, and they couldn't sell it. And so they gave it away to universities. So we
Right.
were one of the first places to be using it. And the mini robot lab in the PDP-11 was that in those days, that was before the VAX came out, and there were
Right.
32 versions of Unix. So
Yes.
Unix was, I think it came out on the PDP-11 as I recall, but they probably had other computers at Bell Labs that were running it on as well. And yeah, so Yeah, we were very, and I still have a copy. There's in those days, Unix was 10,000 lines of code. Okay.
Right.
And there was uh, a fellow in, I forget if it was Australia or New Zealand, who was teaching a class on operating systems, and he did an annotated version of the
Right.
Unix
Right.
code.
Lions.
Yeah, I have a copy of that downstairs. It's probably an interesting historical thing. But there, yeah, so it's 10,000 lines of code,
Right.
and a normal person could actually understand it.
Yeah, that's
Okay,
nice.
particularly with this work that had been done on annotating and, sort of adding comments and stuff. Um, and in fact, I later on went to work for Interactive Systems, which was a company that was founded to support Unix, since the AT&T couldn't do it. It was out of Santa Monica. And they went around, and in those days, there were no two Unix installations that were even close to being the same. Okay, in order to make it work, you had to modify it.
Right.
Right. Because, well, I guess you could make it work on a PDP-11 if you didn't have anything attached to it. But of course, we had to write all kinds of drivers and stuff
Yeah.
for it to make it work in that environment. And then that's what interactive systems would do, is sort of configure versions of Unix for a lot of government sites, but also commercial sites.
Okay.
Because if you wanted to buy Unix, it was $10,000 with no support. So here's the code. You have the right to use it. Give us the $10,000, because they had to prove to the government they weren't being competitive. And
Right.
so there was this niche for a company to come along and support the Unix operating system, which, yeah, I was working for them for several years. I was working in Colorado, but they decided to start a research lab, and Ned Banta, who was running it, liked the Colorado mountains. And so we wanted to actually do it in this little town called Allens Park. And we ended up in Estes Park, which is where the Rocky Mountain National Park is. And the reason we had to move up the road to Estes Park was there were no single phone lines. Everything was a party line.
Okay.
And in those days, we had phone-based networks, because you couldn't be on the ARPANET.
Yes.
That was pre-internet. So you had to develop your own networking stuff based on phone lines, and probably 1,200 baud modems, maybe. I think we had gone past 300 at that point. So it's very funny when people talk about how slow their internet connection is. I use 300 baud modems.
Yeah.
Yeah, I worked at BBN when they were running the ARPANET. There's funny stories from those days too. But yeah, so they had what you now think of as a standard network control center. Lots of big screens and stuff like that, which are super expensive in those days to try to keep track of the ARPANET. And that was all out of Cambridge, out of BBN. Yeah, so, but yeah, in terms of, I don't remember too much of the Lisp stuff I was doing in those days. I think I was spending more of my time in the mini robot lab.
Right.
But it was definitely splitting time, which was sort of two different communities inside the labs.
Yeah, I get the feeling that the mini robot was a distinct community, and it didn't interact as much with the other groups.
Well, we sort of interacted socially, certainly, because it's not a very big space. But in terms of work, yeah, I'd say the vast majority of the actual work going on there was off of the PDB-10 and the Lisp stuff. Most people were very interested in sort of higher level understanding systems and things like that. And the mapper was really a way, I think, to integrate some of that if people wanted to do list-based vision stuff, they could, but I think most of the vision work in those early days was in the mini robot lab. You know,
Right.
yeah, but that was, as I say, it was Bert Horn that was really my direct advisor, and for the undergraduate work. Yeah, a nice guy.
Right. So if you're curious, there is a way to request your files from MIT, from the
Oh,
backup
okay.
tapes.
Oh, okay.
So if you like, I can send you that information
Yeah.
later.
Yeah, it might be fun to have electronic copies of these
Yeah,
things
sure.
and see. You know, I probably have somewhere in the basement. I think I still got some fanfold printout of some of that assembly language.
Yeah.
That'd be more interesting to look at it electronically these days.
Yeah, probably.
For sure. Well, yeah, I'm happy if other questions come up. Yeah, happy to try to help you out any way I can.
Yeah, thank you very much. I'll get back to you if I can think of any other questions, but
Sure.
I'm
Yeah, it
good
was
for
an
now. So
interesting time to be in that field. I mean, Uppsala had 200 or 300 people. You know,
right.
it was a
Yeah.
very small. The AI community was really pretty small
Yeah.
in those days, and that's totally different now. It's sort of, well, it was very funny. We used to joke that we were in the Department of Electrical Engineering and Computer Science, ECS, and I thought it was only short matter of time before it became the CSEE department, right? Because
Yeah.
even when I was there, computer science was sort of taking, well, the digital electronics was taking over, so computer electronics, and the only analog stuff that was going on there was designing high power systems and antennas and stuff.
Yeah.
And so I assumed that long before now it would have switched to the CSEE and eventually maybe even dropped the double E, because it was, you know, I was obviously biased. But it's still ECS.
Yeah.
So, yeah, so who knows? A lot of politics involved in university.
I'm sure.
Well, very nice meeting you.
Yes, you too. Thank you for talking to me.
Oh, you're very welcome. And yeah, just let's stay in touch if you have any other questions or anything I can try to help you
Yeah,
with. I'm
that's great.
sorry
Thank
my
you.
memory is so foggy of those days.
Yeah, of course, it's been a while.
Exactly. Well, take care. Have a good day.
Yeah, you too. Thank you.
Okay. Bye-bye.
Bye.